Hello, my name is Peter Pesic, and I'm a part of the senior design group that was in charge of reinvigorating a pre-existing experiment here in the Aerospace Experiments Laboratory course at the University of Central Florida. One of the problems that UCF was facing with their particle image velocimetry lab, PIV, was that their test object would never stay where the experimenters intended for it to remain. Therefore, without a properly secured testing rate, experimenters were having trouble gathering data that was usable. Furthermore, any data that was collected was taking upwards of 20 minutes per experiment to collect. Not a great timescale for a university lab that claims to be up to snuff with industry standards. Therefore, when it became time for us to raise the standards of this lab, our team first decided to address the support structure. The PAOAI, the Precise Angle of Attack Indicator, the crown jewel of this year's senior design project. One of the first improvements that our customer requested that we make in our design was a way to easily manipulate the angle of attack of the test object without sacrificing rigidity, all while ensuring that the test object remains stable during experimentation. The PAOAI has a maximum operating angle of positive 50 degrees and negative 50 degrees, as shown by this custom machine protractor installed on the device's face. Additionally, it was designed to be future-proof in its ability to support myriad test objects, so this lab will be able to continue on for many years with any test object that our customer may ever desire. Now let's discuss some of the other improvements that the team made, such as improving the post-processing time of the original experiment by nearly 800%.
So, as Peter was saying, this software allows us to get much higher quality data in a much shorter period of time. As you can see here, I just ran a simulation on 160 images, which with our camera and our setup equates to about 1 second of data, or not about, but exactly 1 second of data. You can see here the time elapsed on the calculation was 1 minute and 55 seconds. We did some tests earlier in the spring semester where we calculated, or we timed the Dantec software to be upwards of 18 minutes, usually around 20 minutes. So this is about 10 orders of magnitude better than the previous Dantec software. This software also allows the students to have a lot more control over their data and the quality and the quality and the speed at which it takes to process. So you can see here I did a flat plate. This was one of the models that we printed as a group and have set up in the tank now, and this is a test run that we were doing. You could see here that this is just a transient case, so I could flip through here and see each frame, how the flow is changing with each frame. And then I can also get a time averaged view here. If I go here, this is the time average view of the flow. As you can see, it's a lot cleaner. And the longer that you actually run the camera and collect more data, you can get even more high quality flows in the time average sense, because you have more data to calculate off of.
We learned a lot while working on this year-long project, so now let's hear what the team thought of this entire project as a whole.
So a challenge that we faced during planning was definitely scheduling, especially with everyone taking different classes. It was just a lot of planning, a lot of, meetups and filling out Excel spreadsheets and just getting everybody to try to work together and distribute the workload evenly was another challenge.
What motivated me during our senior design project was the community that we had built between each other as a team and the ease of communication between us. We were lucky that all of us were team players and will work together to see the project through to completion in order to not let each other down.
So we met with Dr. Mancy about our lab manuals, and he had a lot of great points and constructive criticisms on things that we could either add or do differently in our lab manual. And that's stuff that we are adding to our lab manual right now. So we are trying to take all of the things that our professors are suggesting that we do, put our own spin on it, and then incorporate that into our project. So we don't want it to be all them or all us. We want it to be a together type thing.
for me, what I would say the biggest lesson that I learned that I could apply to the industry is that really, this applies to a lot of things as well, but things don't always work out as you'd want them to work out. And, even though our shareholders or the professors that we had were helping us throughout the way, they really were only available at very specific times. So everything that we did for our project was not only did we have to plan around our own schedules, but also plan around their schedules. There was some things that we couldn't progress, not because we weren't ready, but just because of other people's schedules also conflicting. So that really showed me, just for getting into the industry, to kind of expect everything. You always have to have stuff pretty strictly planned out if you want to see consistent progress. And I guess just greater planning skills is really what I got from this senior design project.
My motivation to choose this project was basically research, because the first assignment that we had was a technical memo, and to write a technical memo you need to do research about PIV. I will be starting my internship at UCF in spring 2023, where we do research not in my PIV but in micro PIV, a slightly different topic, but still you need the basis for the PIV to learn about this. So this project really helped me to concentrate on my research as well.
My motivation for particularly choosing this project was Dr. Mazumdar. I won't lie, I saw his name on the senior design list, and he was not the only one I recognized, but one of the only professors that really kind of just stood out to me during my undergraduate career. I loved his thermodynamics class. I loved his heat transfer class. He's a great guy. He teaches really well. And for senior design, I really didn't know what this class entailed. I didn't really know what was going to be asked of me. But I knew that if I had Mazumdar as my advisor, it would be a lot easier to go through this course, to go through the unknown. And so that's why I chose him. I picked this project as well as one of the other projects that he was listed as faculty advisor for, put those as my top two, and the rest is pretty much history. So that was definitely the only motivation in choosing this project. But also, in hindsight, PIV is pretty cool. So there we have it. Senior design is over, and our team is on to our next greatest adventure. Thank you for joining us here today. And as always, go Knights, charge on.